Hi guys, today we are going to discuss about common gate amplifier. It is called a common gate amplifier because the input is given at the source terminal and the output is taken out of the drain terminal while the gate terminal is held at a constant voltage. It is ideal for high frequency applications and impedance matching due to its low input impedance and high output impedance. The three terminologies that we are interested in for the common gate amplifier is the voltage gain, input resistance and output resistance. First, in order to derive these terms, we need to draw the small signal model of the system. Here I've drawn the small signal model of a common gate system, of a common gate structure. The gate terminal is grounded while the input is connected to the source terminal and the output is taken out of the drain terminal. And the RD, this is RD. The RD is grounded, which is generally connected to VDD, but in a small signal model, it is considered as an AC ground. Voltage gain is defined as V out divided by Vin. Let us consider just the V out in this small signal model. The V out can be defined as minus I into RD, and the current is simply equal to GM into VGS. VGS is the gate voltage minus the source voltage. Since the gate terminal is grounded here, the gate voltage is 0 while the source terminal is connected to the input voltage. So VGS is equal to 0 minus Vin. So VGS is equal to minus Vin. Substituting these terms in the output voltage term, we get that Vout is equal to GM into RD into Vin. Thus, the voltage gain is equal to GM into RD. As you can see here, it is the same terminology as the common source amplifier, but in the common source amplifier, it is negative, and in this case, it's positive. Similar to how we derived in the common source amplifier structure, in this case also, the input resistance is defined as a test voltage divided by a test current. There is a small modification that we need to make in the small signal model. I have injected a test voltage into the input terminal, which is the source terminal in this case, and we can calculate the input resistance from this. Since the current flows in this direction, I test can be written as minus GM into VGS, since the current would be inverted due to the direction. VGS is defined as the gate voltage minus the source voltage. We already know this. There's a small change in this case. The gate voltage is 0 since the gate terminal is grounded, while the source voltage is connected to a test voltage. So Vs is Vtest. Hence the gate to source voltage is given by minus Vtest. Hence Itest is equal to Gm into Vtest. By rearranging this, we get the input resistance as 1 divided by Gm. You can see that the input resistance is independent of RD and the input resistance was infinite in the case of common source amplifier. The output resistance is also same, but we just inject a test voltage into the output terminal. So the output terminal is the drain terminal in this case. R out is equal to Vtest divided by Itest. And this is a simple KCL. So the incoming current into the node is equal to the outgoing current from the node. So the incoming current is the Itest, and the current going out into this branch and this branch are the outgoing currents. So Itest is equal to Vtest divided by RD plus Gm into VGS. Let's calculate VGS now. VGS is gate voltage minus source voltage. The gate voltage is 0 since the gate terminal is grounded, but this time even the source terminal is grounded, so the gate to source voltage is 0. And we know that the source terminal is grounded because that's how output resistance is defined. All the independent sources are grounded while calculating the output resistance, except the V test, obviously. And oops, okay, R out is equal to V test divided by I test. By rearranging these terms, we get that the output resistance is equal to RD. Thank you so much for watching, and see you guys in the next video. Bye.